fourth graders. So before I jump into today's math lesson, I just want to share a few reminders to keep in mind moving forward. So I know last week we were probably all at different places with our math lessons, and that's okay. Moving forward, the first couple here might sound familiar or it might be brand new learning, and that's okay. We'll just move forward from here and everybody will be at the same place pretty soon. So that was my first reminder about that. The second reminder that I'm sharing is after today's lesson, I'll let you know what student book pages to work on. And the idea is after you complete them, take pictures of the workbook pages, of your student book pages on your Chromebook and post them in your Google Math slideshow. And the idea is each day we'll just keep adding to that same slideshow. And my last reminder, when you have shared the Google slideshow with your teacher, just make sure that you gave your teacher editing rights so that the teacher can comment back to you right on the actual Google slideshow itself. All right, so for today's lesson, we are continuing on in Unit 6. It's called Multiplication and Division, Data and Fractions. And for today, Thursday, March 19th, we're moving on to our new module, Module 2, and we'll be in the first session, and it is titled Area Problems. So before we get too much farther into our lesson, let's make sure about a few area concepts that we have worked on in the past. So this is our vocabulary card that you may have seen, and it reminds us that area is the total number of square units needed to cover a two-dimensional surface. And in addition to that vocabulary card, keep in mind that when we are recording area, we're recording it in square units. If your dimensions are inches, then your area is recorded in square inches. If your dimensions are centimeters, then you are reporting the answer in square centimeters. For example, if we have our rectangle and we're wanting to find the area, which is the inside, we can use our area model. We have our two dimensions. The shorter dimension is our width. The longer dimension is our length. And we'll just use easy numbers right now for this example. So our width is 4, and we'll use inches. And the length is 5, and we'll use inches as well. So when we're using our area model, we could look at it as I'm multiplying my dimensions together, and then that will give me my inside area answer. So in this example, 4 times 5, and we have a total inside area of 20, and then here's where we need to remember square inches. Now from this area model, we remember we can actually make four facts, 2 multiplication facts and 2 division facts. This is going to come in handy later on in the lesson because we're going to shift from using our area model as only really helping us to find multiplication answers. We're going to shift a little bit to using the area model to help us with division problems. So for this example, our 2 multiplication problems would be, you could have it as 4 times 5, of course is 20 again, or 5 times 4 is 20, and in this case you would say square inches. Now let's take a look at how we can use this area model to help us with our division problem. So we would start with the larger inside area of 20. We'd go to one of our dimensions and divide that dimension. And then that would give us the answer to our other dimension. And of course we could go about it the other way as well. 20 divided by 4 20 divided by 5 rather equals 4. So we could make our two multiplication problems and we could make our two division problems from our area model. All right, well, let's see if we can continue on with that same area model, remembering that easier problem that we just worked with, and now use that to help us build on that strategy for more challenging problems. So if we look at this area of 252 square meters, and we know that one of our dimensions is 7 meters, we're also trying to find our missing dimension, which is the length in this case. So we could look at it in a couple of different ways. We know that if we multiply for our area formula of width times length, that will give us our area, or length times width will give us our area. So that could possibly be a starting point. We could have 7 times something is equal to 252, or we could start with our missing dimension, multiply it by 7, and that will also get us to 252. But that's really a large multiplication fact that many of us don't have memorized. So as we move along farther in the lesson, we're going to see how we can break down our area, our large area, into smaller areas to finally figure out this missing dimension. So we're going to kind of have to start looking backwards a bit. I know that in the past, we've really used our area model as a multiplication strategy. Well, now we're really going to be taking a big step and trying to use our area model as a possible strategy to help us with some division problems. So we would have our inside area, in this case, 252 square meters, divided by our known dimension of 7 meters, and then that will give us our unknown dimension. So a division problem of 252 divided by 7, or still starting at 252, dividing it by our unknown dimension is equal to 7. So making it into those two division problems. All right, well, let's take that next step of seeing if we can tackle this problem together. And I'm going to erase my 252 because from here, I'm going to know that my inside area is 252 square meters. And this whole thing now, I'm going to work on breaking it into smaller areas that eventually I can add up that will get me to my 252. For example, we know that we like to work with 10 a lot because 10's an easy number to multiply. So I'm going to start by dividing my large rectangle, which I know is 252 square meters, into sections of 10 and get as far as I can get, or get as close as I can get to 252. So I'm going to start here, and I'll say this is 10 here, so 10 meters. So this would be a 7 by 10, smaller area. And I know that 7 by 10 will get me up to 70. So that's still a little bit of a distance away, but I'm getting closer, and that's a good thing. So now I want to go again and divide it up. And this time I'm going to go with 10 again. And I already know that this was a 7 by 10. So this is also a 7 by 10. So this is going to be 70. So from here, my two 70s are going to get me up to 140. Well, I'm getting closer, but I still have a little ways to go. So I'm going to go ahead and divide it up again into 10. So again, I have a 7 by 10, which will again get me up to 70. So I have 70 plus 70 plus 70, which is now, or 70 times 3, and I might want to write this off to the side, 70 by 3 is 210. And that's really, really close to this number. So from here, I want to know the difference between 210 and 252. So that might be a little bit of some extra work. Off to the side, you might have to subtract 252 minus 210, and then that would be a difference of 42. So I know that I need to get up 42 more here, because this number plus this number plus this number plus this number is now my area of 252 square meters. So working backwards, I have 42 divided by 7 is equal to what? Or 42 divided by what is equal to 7? Or I have what two numbers can I multiply together that would get me up to 42? And that answer would be 6. So now what I've done is I've broken my larger rectangle of 252 square meters into smaller, more manageable areas. And if I add up all of these smaller areas, that gets me up to my 252 square meters. And I know one of my dimensions is 7. Now my other dimension is 10 plus 10 plus 10 plus 6. So this other dimension is, sorry, I'm running out of room here, 36. So using what I've known for my easier area models, I can hopefully start using that for some of these more challenging problems. So now if I look at what I have 7 times 36 equals 252, or I have 36 times 7 equals 252, or my two division problems. 252 divided by 7 is 36. 252 divided by 36 is 7. So I have those 4 different facts that I can rely on to help me find some of these missing dimension problems. So our linear measurements are the width and the length, and up here this would also be meters. And then when I have my area, again, I do need to square my dimension, my units of measure. All right, so this is kind of the big idea of where we're trying to head. I know that this is a lot, especially with these larger numbers, and the numbers are going to keep getting larger. But if we can rely on what we know about breaking a number up into smaller numbers, breaking our larger area model into smaller, more manageable pieces, I think we're going to start finding some success with some of these types of problems. So I'm going to pause this for a minute, and I'm going to use the same problem, but I'm going to divide my area up in a different way, and you can see how that could also be a possible way to go about using the same area model strategy to solve this larger division problem. All right, well, let's take a look at the same problem again. 252 divided by 7 equals 36. We found that out in the last example. This time, I broke my area model up into different chunks. Last time my chunks or smaller areas were 10, 10, 10, and 6. This time I decided to break it up into 20, 10, and 6. I could figure out that 7 by 20 got me up to 140, and 7 by 10 got me up to 70, and again 7 by 6 got me up to 42. So from here I can add 140 plus 70 plus 42, and I get my same answer of 252. So my dimensions are a 7 by 36 multiplied together will get me up to a 252. So students, I know that that was a big jump from the easier types of multiplication area problems, using the area model rather, that we've been working with. So we'll take this slow. We'll continue to practice this moving forward. Some of you might even want to challenge yourself a bit and see if you can solve these same types of problems, possibly using a ratio table, because those are two big strategies we can go to, a ratio table and an area model, to help us with some of these larger division problems. All right, so let's take a look at what your student book assignment is going to be after we finish up this lesson. So today, take a look at student book pages 224, 225, and 226. There are no home connections to match with this session. I know that that's a lot. Let's go ahead and just give it our best effort. Give it your best try. Experiment with breaking up that larger number in the division problem into smaller areas, and just spend some time kind of exploring it and giving it your best go. So that was today's math session for our Unit 6. We moved on to Module 2, has a heavy focus on area and perimeter, using ratio tables as well as the area models that we looked at today. Please take your pictures of the workbook pages, student book pages rather, upload them into your Google slideshows. Continue that same one. We're just going to keep adding to that same one. And if you do have questions or hang-ups, ask your teachers questions right on your Google slides. I think that that will be helpful and we can respond back. So again, this was my first YouTube experience and first time really videoing something like this. So I know that with time I'll continue to get better and have a little bit more information to share with you in the future. So thanks again, Riverside students, and I'll see you soon.